Welcome, students. Since we won't be able to be in class on Thursday, I thought I would make a video for us so that you can go over all of the problems and fast forward through the ones that you don't have any problems with. And then you can pause on the ones that you need help with and go through those individually. So let's begin with lesson 69 through 70. That was Monday's work. We were supposed to factor each of these. So whenever we factor, we're looking for the third term, that the factors of the third term that when added together give us the coefficient of the second term when these are written in descending order. So that just means we're going to factor this as a binomial. We'll put x in the front of each one of these. And when we factor negative 42, we know that those factors are 6 and 7. And because we want to have a negative 1 remaining, we know this 7 is going to have to be negative in order to get that. So that's going to be x minus 7 plus 6. Here we have just the opposite. So the 7 is going to be the positive number here. It's going to be x plus 7 and x minus 6, because we still, with those two factors, can get negative 42, but we need to have a positive 1 remaining, so we just flip the signs, and then when we add positive 7 negative 6 together, we get a positive 1. Looking at number 3, we are going to create our binomials here. X goes in front. Negative 16, that gives us a negative 6 when combined. That's going to be a negative 8, positive 2. When you add them together, that's what you get. So negative 8, positive 2. Here, we're going to look at positive 9. That gives us a negative 6 when combined. The only way we can do that is negative 3 times negative 3. So x minus 3. X minus 3 is how we would factor that. For number 5, we're looking at negative 27. What factors of negative 27 would give us a negative 6? And that would be negative 9 times a positive 3 would give us negative 27, but when added gives us a negative 6. So x minus 9, x plus 3. Number 6, we have a variable change, so when you write your answer in, make sure you put the right variable, and we're looking for negative 20 factors that would give us a negative 1 when combined. That's going to be negative 5, positive 4, because that gives us a negative 1. So p minus 5, p plus 4. Here, we're going to factor into two binomials. We're looking at negative 15. That gives us a negative 2. This is going to be negative 5, positive 3. Multiply them, you get negative 15. Add them, you get a negative 2. So x minus 5, x plus 3. Let's factor this one, but first we've got to, no, we don't have to do anything here. We just have to factor it out, and we have to remember that it's p and not x. So we want a negative 21. That also gives us a negative 4. That's going to be a negative 7 times a positive 3. When multiplied, we get this. When added, we get this, so that's correct. P minus 7, p plus 3. We're going to rearrange these in descending order of the variable and then factor. So x squared plus 14x plus 33. Now the only factors of 33 that I can think of are going to be 3 and 11. And that gives a positive 14. So we know the only way to factor that is going to be x plus 3 times x plus 11. We're going to rearrange this one. Not very hard. M squared minus m minus 30. We're going to factor that. We're looking for negative 30. That when combined gives us a negative 1. So that is going to be negative 6 and a positive 5. when multiplied gives us negative 30. When combined gives us a negative 1. So m minus 6, m plus 5. Now let's go into some probability and statistics. So a fair coin is tossed 3 times. What is the probability that the first time it comes up heads and the next 2 times it comes up tails? So we write that like this. The probability that we will have heads, then tails again. So whenever you have a coin, you only have 2 outcomes. You have either heads, you have tails. So either one of these outcomes is 1 out of 2. So that's what we're going to do for each one of these. 1 out of 2 for heads, 1 out of 2 for tails, 1 out of 2 for tails again. And we're going to multiply them against each other and have 1 out of 8. That is the probability that we'll get heads, tails, tails when we flip it 3 times. So we're going to take that same coin and we're going to flip it 3 more times. And we want it to come up heads all 3 times. Does what we want it to come up change its probability? Absolutely not. You have a 1 out of 2 chance you're going to get heads on the first, 1 out of 2 chance you're going to get heads on the second, and 1 out of 2 chance you're going to get heads on the third. So you're still going to have a 1 out of 8 probability of tossing heads, heads, heads. So now let's look at 13. We've got a spinner. And it's got 4 spaces on the spinner. 1, 2, 3, and 4. Here's our little arrow. We're going to spin. And we're asking, what is the probability that the spinner stops on 2, then on 4, then on 3? So we're going to assume that this is a fair spinner. It's not weighted in any kind of way, which means everything has an even and equal chance. So that means when it lands on 2, you have a 1 out of 4 chance it lands on 2. Which also means if you hit 4, it's 1 out of 4 choices. So 1 out of 4. And 3 would be 1 out of 4 also. So 1 times 1 times 1 is 1. And 4 times 4 is 16, times 4 is 64. So you have a 1 out of 64 chance that it's going to land on 2, then 4, then 3, if you spin it 3 times. Now we have 2 dice. So we're going to roll these 2 dice, and we're going to talk about the sum of the numbers. So in order to do that effectively, we need to create a little table here. So 1 dice is 1, 2, 3, 4, 5, 6 faces on that 1 dice, right? So when we roll it, it could land on any one of these. When we roll the second one, it could be a 1, a 2, a 3, a 4, a 5, or a 6. And when we add those 2 dice together, we get a sum. 1 and 1 is 2, 2 and 1 is 3, 3 and 1 is 4, then you have 5, 6, and 7. Same thing here, 1 and 2 is 3, 4, 5, 6, and 7. 2 and 2 is 4, 3 and 2 is 5, 6, 7, 8. 3 and 2 is 5, then 6, then 7, then 8, then 9. That's 6 and 3 is 9. 4 and 2 is 6, 4 and 3 is 7, 4 and 4 is 8, then 9, then 10. 5 and 2 is 7. Then you have 8, 9, 10, and 11. And then finally, if the first one is 6 and the second one is 2, you get 8. Then 3 is 9, then 10, then 11. And when you have 6 and 6 together, you have 12. And that's the only way. So these are all the possible outcomes. And if you look, you've got 6 rows of 6 outcomes. So 6 times 6, you have 36 outcomes. So what is the probability that the sum of the numbers rolled is 4? So let's get our highlighter and let's find all the 4s. 1, 2, 3. So we only have a 3 out of 36 chance that it'll be a 4. If we reduce that, we get 1 out of 6. So we have a 1 out of 6 chance of rolling a sum of 4. All right, so what is the probability that'll be greater than 9. So that means greater than 9, the sum would be 10, 11, or 12. So we only have 36 outcomes. So let's see how many of those outcomes could possibly be 10, 11, or 12. So 1, 2, 3, 4, 5, 6. So 6 out of 36 opportunities to have a number greater than 9. We reduce that and we get 1. I'm sorry, I did this wrong. My goof. That should be 1 out of 12, not 1 out of 6. This one is 1 out of 6 because 6 divided by 6 is 1 and 36 divided by 6 is 6. This would be divided by 3, divided by 3. So this one is 1 out of 6. This one is 1 out of 12. So I'm sorry, I did not mean to make that mistake. It's okay. A single die is rolled 3 times. So let's think about a single die. Here's one single die. You have 1, 2, 3, 4, 5, 6, right? What is the probability the next roll will produce a number greater than 3? So greater than 3 is our probability. We have 6 possible rolls. So greater than 3, that would be 4, 5, or 6. So that's 3 greater than 3. 3 out of the 6, which we know reduces to 1 over 2. So we have a 1 out of 2 chance of rolling a number bigger than 3. Now we're back to rolling 2 more dice with problem 16. What's the probability that the sum of the numbers rolled is 6? So let's count the sum that could equal 6. So we've got, let me go with yellow here. 1, 2, 3, 4, 5. There's 5 opportunities or 5 combinations where the sum is 6. So that's 5 out of 36. And we can't reduce this because 5 is a prime number and it doesn't have a factor in common with 36. So that would be the answer for number 16. Let's move on to number 17 and let's do the earn problems. I love doing earn problems. So for number 17, we have an earn. We're going to make it a little fancy. A little earn like that. And it contains 6 pink marbles. 1, 2, 3, 4, 5, 6. That one's kind of skimpy. Let's beef it up a little bit. There we go. Now these look small. Let me see if I can beef them up. Okay, those look good. And 7 blue marbles. Let's do 7 blue marbles. 1, 2, 3, 4, 5, 6, 7. Oh, we barely got them all in there. So we have 6 pink and 7 blue, which means we have a total of 13 marbles. Okay, so it contains 6 pink and 7 blue. A marble is drawn and dropped back in, which is awesome because this doesn't change. A second marble is drawn and dropped back in. That's awesome. This still doesn't change. Both marbles were pink. That's great to know. If another marble is drawn, what is the probability that it will be pink? The probability that it will be pink is we have 13 marbles and 6 of them are pink. So we have a 6 out of 13 chance of drawing a pink marble. That's it. So let's look at another urn. I'm going to draw another cute little urn over here. This one, I'm going to make it even fancier. Look at that. Put it on its little stand right there. All right, now in this urn, we have 5 green marbles. So 1, 2, 3, 4, 5, and 9 purple marbles. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. So we have 5 green and 9 purple for a total of 14 marbles. So a marble is drawn and dropped back in. So this doesn't change. A second marble is drawn and dropped back into the urn. This doesn't change. We still have 5 green and 9 purple. Both were green. That's awesome, but there's still 5 green ones because we put them both back in. So if another marble is drawn, what is the probability that it will be green? Well, we have a total of 14 marbles, and 5 of them are green. So 5 out of 14 is our probability of drawing a green marble. Last problem of Monday's work. A single die is rolled 3 times. Okay, what is the probability that the next roll will produce a number greater than 4? 1, 2, 3, 4, 5, 6. That's all the possible outcomes. So there's 6 outcomes. Of those outcomes, 5 is greater than 4 and 6 is greater than 4. So the probability that we will roll something greater than 4 is 2 out of 6 outcomes, which we know we can reduce to 1 out of 3. So this would be our answer. And that's all of Monday's work. We did all of Monday's work in less than 16 minutes. Look at that. So it's not really a whole lot. Not truly. So 16 minutes worth of homework on Monday. I think y'all got it pretty good. So let's look at Tuesday's work. All right, lesson 71. We are going to write each factor in a different blank. And what we're going to do is we're going to find the greatest common factor first. Obviously, we cannot factor x cubed. That means something has to come out of each one of these to reduce it down to make it something that we can factor as a trinomial. So we're going to find the GCF, and in the first term, I see this -4, which is a clue. We don't want a coefficient on our x term. And we know we've got an extra x in here. We also have an extra x in each one of these. So I'm going to take -4x out. So -4x out of that is going to leave me a trinomial of x squared. -28 divided by -4 is going to give me a positive 7x, because one of these x's goes away. And -48x divided by -4x is going to give me a positive 12 with no x. So in order to get a positive 12 and a positive 7, I know I'm going to multiply positive 3 times positive 4, because then that gives me positive 7 when combined. So it'll be -4x times x plus 3 times x plus 4. So that is what goes here. All right, let's look at the next one. So the only thing that we really have is we don't want to do a negative on our first term. So we're going to take that out. So we're going to take out the -1, and that's going to leave us x squared minus 2x, because this should go next, minus 24. So when I factor that, I want a -24 that leaves me a -2. So that's going to be a -6 and a positive 4, because when I combine those, I get a -2. So x minus 6, x plus 4. And then I still have that -1, or you could just have the negative symbol. Either one would be correct. X minus 6, x plus 4. And that's how you'd factor that. Now we're going to use substitution to solve here. So we've already got a substitution value for NQ, and that's NN plus 5. So I'm going to rewrite this with my substitution value. So 6NN plus 24, and the value for NQ is NN plus 5. And that equals 360. So now I'm going to distribute 6NN plus 24, NN plus 24 times 5 is 120. I just had to think for a minute. I'm going to subtract 120 from both sides, and I'm going to combine my like terms. This would cancel, and that would give me 30 NN is equal to 240. So when I divide both sides by 30, NN is equal to 8. So NN is 8. So if NN is 8, then this is going to be 8 plus 5, which is going to equal 13 for the value of NQ. All right, we're going to do the same type of thing with number 4, except that we don't have a substitution value ready. So I'm going to subtract ND from both sides, which means my substitution value is NN is equal to 12 minus ND. And I got that by just subtracting ND from both sides, right? So that gave me this. So this is my substitution value for NN. So I'm going to rewrite this substituting that in for NN. So 6, and here's my NN, 12 minus ND plus 12 ND is equal to 180. So 6 times 12, that's 72, minus 6 ND plus 12 ND is equal to 180. Subtract 72 from both sides. Combine like terms. 6 ND is equal to 108. And I'm not doing that in my head. My brain is hurting today. I've done a lot of math. So 108, I'm going to do it on the calculator, divided by 6 is equal to 18. So I divided both sides by 6. ND is equal to 18. So I can come over here and sub in 18. 12 minus 18 tells me that NN is equal to -6. All right, back to factoring. So we don't want the coefficient. So our very first term is 2. So when I take 2 out of each of these, I get 2 times x squared plus 5x plus 6. So I can factor that with binomials. I want to get 6, positive 6, that needs to equal 5. So that's going to be plus 2 plus 3. Those give me positive 6. But when added, they give me a positive 5. So x plus 2, x plus 3. Not super hard. All right, now let's look at number 6. First of all, I want to take that negative sign off. And then there's like an extra b in each of these terms. So if I do that, minus b, then I get b squared minus 5b minus 24. Because when you take out that negative, you have to change all these signs, right? Because you're multiplying negative times negative to get a positive. So now we're going to factor this into binomials. And I want that negative 24 that when combined equals a -5. So that's going to be -8 and a positive 3. That's the only way to get that -5 with as factors of 24. So we have b minus 8 and b plus 3. And that would be the right way to factor that. The only way to factor that. All right, let's look at some more substitution problems. We only have 2 more in this lesson for Tuesday. So again, we're going to create another substitution value by subtracting ND from both sides. So that's going to give me NN is equal to 17 minus ND. That's my substitution value for NN. I'm going to put that into this right here. So 5 times NN, which is 17 minus ND, plus 10 ND is equal to 135. So when I multiply this, I know 5 times 17 is going to be 85 minus 5 ND plus 10 ND is still equal to 135. I'm going to subtract 85 from both sides, and I'm going to combine like terms. So 5 ND is equal to 50. So ND, when I divide both sides by 5, is equal to 10. So if ND is equal to 10, 17 minus 10 is equal to 7. So NN is equal to 7. All right, one more substitution, and then we're done with Tuesday's work. And we will have done all of that in around 10 or 12 minutes. So we have a substitution value already given to us here for NQ. So 5NN plus 25 times the value of NQ, which is NN plus 4, is equal to 340. We're going to do our distribution. 5NN plus 25NN plus 100 is equal to 340. Subtract 100 from both sides. Combine like terms. We get 30 NN is equal to 240. When I divide both sides by 30, NN is equal to 8. Well, if I substitute that back in here, then 8 plus 4, NN plus 4 is 8 plus 4, which equals 12, which is the value of NQ. And that's all we had for Tuesday. So we did Tuesday's work in all of 10 minutes. So not too shabby. Remember, pause as you need to solve the problem, to, compare it to what you did on your paper and see if what your mistake might have been if you did not get it right. If you got it right, skip it, fast forward to the next problem. Let's look at Wednesday's work. So I'm going to go ahead and in reviewing this, I realized that you guys have no way of getting this last problem. Well, it's not the last problem, but it is next to the last problem. You have no way of understanding what your slant height is. And your slant height would be this little thing right here. You have the radius of the base and you have the height of the cone, but you don't have your slant height. In order to get the surface of the cone, surface area, you've got to have slant height. Now, we'll get to that in a minute, but because you haven't done that in this book yet, we did it last year in pre-algebra. It's called Pythagorean's theorem. So if you had pre-algebra with me, you do know how to get there. You just might have forgotten. So I'm going to give you a freebie. I'm going to, if you get this one right, it's a bonus point. If you don't, it's not going to count against you. So I decided to do that because that is only fair. So let's just start at the beginning and we'll work our way down to that problem. Most of it's factoring, and it's factoring out the greatest common factor. And that greatest common factor is going to be the thing that is used the most in each term. So here we have an M in this term, an M in this term, and an M in this term. So that tells me that M is one of my factors. We also have y plus 1, y plus 1, y plus 1. So that's another of my greatest common factors. So we have two factors that are singled out so far. So what do we have left? We have x squared plus 4x plus 4. How do we factor that? X plus 2, x plus 2. Because x times x is x squared, x times 2 is 2x, 2 times x is 2x, 2x plus 2x is 4x, and 2 times 2 is 4. So this would be x plus 2, x plus 2, right there. All right, we're going to begin by factoring out the greatest common factor again on this one. So we have m minus b, m minus b, m minus b. We also have a c, and a c. So if we take those out, we have c, m minus b. It doesn't matter what order you put them in. It's going to check each one individually against a list of factors, and they can be in any order, so it doesn't matter. If you put m minus b first, it should mark it right. So what we have left when we get through with that is x squared minus 2x minus 24. So we can factor that into a binomial. We're looking at negative 24. We need to have a negative 2 left. So it's going to be a negative 6 and a positive 4, because when we combine those, we get a negative 2. So x minus 6, x plus 4 are going to be your factors that go here. It doesn't matter which order you write them in. I just started writing a plus sign, so I just switched it. But it's going to mark all of those right. So here, again, same thing. Take out the z minus 5, right? That goes here. Z minus 5. Be very careful when you write your z's. I try to make them very angular so that I can distinguish them from a 2. And when I write my 2's, I typically try to put that little loop in there so that it's clear that that's not a z. So be very careful whenever you do that, just to make sure that you can distinguish between the two in your notes, for the sake of not making a mistake when you type in your answer. So what we have left is x squared plus 5x plus 6. I know, because we've done these before on a previous lesson, that this is going to be x plus 2, x plus 3, because for a positive 6, we can multiply positive 2 times positive 3 and add them together and get a positive 5. So that's my other two factors here, x plus 2 and x plus 3. All right, when we factor this, we're going to pull out the x minus 1 from each one of these terms. So x minus 1 is our greatest common factor, and we have left over x squared plus 7x plus 10. Well, how do we get positive 10? We say positive 2 times positive 5. When we combine those, it's going to be a positive 7. So x plus 2 times x plus 5. Those are our other two factors. All right. Now let's find the volume of the right rectangular pyramid. Pyramid. I can't speak today. So volume of a pyramid is equal to the area of the base times the height divided by 3. So first we need to find the area of the base. And here we have a rectangular base, hence right rectangular pyramid, of 10 by 8. So the area of the base is going to be 10 centimeters times 8 centimeters. And the height is 12 centimeters. All of that divided by 3 is going to give us the volume of the pyramid. So 10 times 8 is 80, and 80 times 12 is going to be, well, heck, let's just pull up the calculator. So 10 times 8 times 12 is 960, divided by 3 is 320. So that's going to be 320 centimeters once, twice, 3 times, so cubed. 320 centimeters cubed. And that is the volume of the pyramid. Pretty straightforward. So let's find the surface area of the cone below. Now I'm going to show you how to do it. For those of you who've had Pythagorean's theorem before, you're going to go, oh, why didn't I think of that? But here is how you do that. We've got to find the slant height of this cone. So in order to find the surface area, this total surface area for a cone is going to be the area of the base plus the lateral surface area. The lateral surface area is going to be pi times the radius times the slant height. Now we don't know what the slant height is. It didn't give it to us, but it did give us the height of the cone. So if we draw a line from the center top of the cone to the center bottom of the cone, and then draw that radius in, we get a right triangle. So this is 9 meters. I'm sorry, wrong one. Excuse me, that caught me off guard. And I had another one. Goodness, excuse me. Woo. So I'm sorry, I got that backwards. The height of the cone is 15 meters. So 15 meters is the height, and 9 meters is the radius. So this creates a right triangle. So those of you who remember from pre-algebra, we can find this slant, which is also called the hypotenuse of a right triangle, through the use of Pythagoras' theorem, which is a squared, a being one of the sides, plus b squared, which is the other side, which is equal to c squared, which is the slope of the right triangle, or it is the side opposite the 90 degree or the right angle, okay? So, if you remembered that from pre-algebra, kudos to you, that's awesome. We didn't teach it until like lesson 117 towards the end of the year, so I understand if some of you were like done by that time. I get it. But if you did remember, then that's awesome. Now you are going to end up with a weird number here. It's going to be a decimal value. But what you would do is you would say 9 squared plus 15 squared, that is the base, the radius times the height, would be c squared. And this would be 81 plus 225 is equal to c squared. And when you add those together, I forget. This was the previous problem. 81 plus 225 is going to give you 306. So what happens is you get 306 is equal to c squared, or this, it's actually the slant height squared, because that's what we're looking for here. That's going to give us that little slopey bit right there. So we unsquare it in order to find it. This cancels this. So then this just becomes this value. But in order to get 306, the square root of 306, we're going to do it on the calculator for now. The square root of that is 17.49. I'm just going to round that to one decimal place to make life easy on everybody. 17.5. Okay. Now, if you did this, you remembered, and you did this, and you put in a value, and it was 17.49, you know, if you got close to the final answer, I'm going to give you credit for it. I'll manually grade it for you and give you credit for that, because I forgot that you have not had this lesson in Algebra 1 yet. It's not until lesson 97 that we do Pythagoras' theorem. And part of that is because I'm doing videos ahead of you guys and putting together pods kind of in line. So I'm a little bit further ahead on what you're capable of than what you actually are. So that's my fault, and I apologize for that. I am going to fix this for next year. I will put in the slant height for next year. So this is 17.5 meters. So there's that. So now we have the slope. So now we can find pi times the radius times the slant height. So it's going to be pi times 9 meters times 17.5 meters. And when we do all of that, we get, let me move this over so we can see it, 9 times 17.5. Ooh, I didn't do that right, did I? 9 times 17.5 is 157.5. So 157.5 times pi meters squared. That is the lateral surface area. Okay, so that goes in here in this calculation. Now the area of the base, we know the area of the base is going to be pi r squared, which is equal to pi times 9 meters squared. 9 times 9 is 81, so that equals 81 pi meters squared. So we're going to add these two together. So that's going to be 81 pi meters squared plus 157.5 meters squared. And when we add those two values together, we add 81 to this, we get 238 times pi, because they both have, oops, I didn't write my pi in here. They both have pi in here, and that's in meters squared. So this is the answer that I'm looking for. If you have an answer that's similar, if you have 238 point whatever, or 237 point whatever, because depending on how you rounded the decimal, you're going to get a different value. But if you have something close to this, I'm going to give it to you. All right, if you have this, then awesome. You rounded it to the same place I rounded it to, which is going to give you the best possible answer. Now, it's entirely possible that you just went ahead and rounded it up to 18. I'll figure out what that is, and if you have that answer in there, I'll give you credit for that as well. So, if you took a stab at it and you got something in the neighborhood, I'm going to give you credit for it. But yeah, what I'm going to do is there's 7 problems here. And this is 1 point. So this one would be 1, 2, 3 points. So it'd be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There's 19 points in this pod that you can get, because each blank is a point. So I'm only going to give you 18 points. So if you get this one, it's a bonus. If you don't, it doesn't count against you. All right, that's the way I'm going to set it up. Let's look at number 7, and then we're done. So begin by factoring out the greatest common factor. Again, a plus b, a plus b, a plus b. So the first one is going to be a plus b. How about that? Then we have x squared plus 8x plus 15. So we factor that into binomials. We're looking for what gives us a positive 15, but also equals positive 8. And the answer to that is going to be a positive 3, positive 5, because there's not any other factors of 15. I mean, that's pretty much it besides 15 and 1. So it has to be those two. 8 plus 3, I'm sorry, not 8 plus 3, x plus 3, x plus 5. So those would be your factors here, x plus 3, x plus 5. And we have just completed all of your homework, including a problem that you didn't know how to do, in under 45 minutes. Every single problem in under 45 minutes. So, I find it very hard to believe that you guys are spending hours and hours and hours and hours. Now, you might be, but I am finding it hard to believe that this is as much as you make it out to be. If you are spending that much time on this amount of homework, then it's because you don't understand something and you need to ask for help. Do not beat your head against the wall. I do not want you to hate math. I want you to, yes, appreciate that it does have a level of difficulty, but I also want you to know that you can do this. It is not so difficult that you can't figure it out. Somebody else with the same brain that God gave them, that God gave you, figured this out in the first place, which means your brain is capable of doing it. Yes, you might see things a little bit differently, but there are other people in the world who see things the same way that you do, who have figured it out as well. God made you able to do it. So let's do it. And it's okay if you need to ask for help to get there. In fact, it's probably a good idea to start there. Say, hey, Mom, can you sit with me when I do my homework? Just in case I have any questions, would you, let me know when you're doing dishes, and I'm going to sit in the kitchen and do my homework then. So if I have a question, you're right there. And that's perfectly okay. Get the help, resources, whatever around you. Get your support system set up and go after it. Ask for help when you need it. You are all smart enough and capable enough to do the hard things. God made you capable to do the hard things. And yes, it is hard. That doesn't mean it's impossible. All right, I want you guys to stay warm. Don't get out in the snow unless, you're building a snow fort. But be careful. Don't travel unless you have to. Stay warm. Have some hot go-go. And I will see you next week.